Welcome to this explainer. If you grew up completely mesmerized by Flash Gordon or Star Trek, you're definitely in good company. Those stories literally inspired brilliant minds like Edwin Hubble and Carl Sagan. Today, we're taking that exact same inspiration and putting science fiction to the ultimate physics test to see what's actually possible.
But hey, before we start throwing around the word impossible, let's just consider Lord Kelvin for a second. Back in 1899, this prominent physicist confidently declared that airplanes were impossible and that X-rays, just a total hoax. And get this, even Albert Einstein in the 1930s believed an atomic bomb was impossible. So looking at our modern world, we quickly realize that impossible is usually just a temporary state of technology. It basically just means we haven't quite mapped out all the fundamental laws of physics yet.
Here's our agenda for today. First, defining the impossible. Second, building a real force field. Third, the science of invisibility. Fourth, phasers and Death Stars. And finally, quantum teleportation explained.
Section 1. Defining the impossible.
Okay, to set some ground rules here, we're going to use theoretical physicist Michio Kaku's framework for categorizing what is truly impossible versus what's just, beyond our current reach. At the very bottom, you've got Class 3. These are the incredibly rare technologies that actually violate known physics. No way around it. Then there's Class 2, which might literally take millennia to figure out. But our focus today, we're looking squarely at Class 1. These are technologies that might be completely impossible to build right this second, but they absolutely do not violate the known laws of physics. Which means, crazy as it sounds, they could be sitting right in our living rooms in the next century.
Section 2. Building a real force field.
So because natural forces like gravity or electromagnetism are either way too weak or just too easily bypassed, a real force field wouldn't be just one magical shimmering bubble. It actually requires a multi-layered approach. Step 1 would be a supercharged plasma window, basically a gas heated so insanely high that it traps air and instantly vaporizes any incoming metals. Step 2 is a laser curtain. Picture a dense, crisscrossing lattice of laser beams designed to heat and disintegrate anything that manages to slip through. And finally, Step 3 requires a screen woven entirely from carbon nanotubes. These are tiny structures literally one atom thick, but immensely stronger than steel, acting as the ultimate physical barrier. Pretty wild, right?
And the cool thing is, force fields aren't just for defense. They're actually the secret to defying gravity. If scientists can ever discover a room temperature superconductor, which is the material that loses all electrical resistance without needing to be supercooled, it would spark an absolute industrial revolution. Through something called the Meissner effect, these superconductors literally expel magnetic lines of force. Put simply, your morning commute could eventually be in a magnetic hover car floating effortlessly over the pavement.
So, we know that with enough stack technology, we can potentially deflect incoming attacks or even float above the ground. But what if you don't want to deflect an enemy laser at all? What if your goal is to make sure they can never even see you in the first place?
Section 3. The science of invisibility.
For well over a century, physicists just flatly stated that true invisibility cloaks were completely impossible. They violated the laws of optics, end of story. But modern science is rewriting those exact textbooks right now, using metamaterials. These are exotic, laboratory-created substances with optical properties you just won't find anywhere in nature. Think of a river flowing around a boulder. The water wraps around the rock and continues smoothly on its path, completely washing out the presence of the boulder downstream. Metamaterials do this exact same thing. By manipulating the index of refraction, they force electromagnetic waves to meander and flow completely around an object, effectively making it invisible. It is truly amazing.
And the craziest part? We've actually done this. Back in 2006, scientists successfully cloaked an object from microwave radiation. But there is a massive difference between microwaves and visible light. Microwaves have a wavelength of about 3 centimeters. Visible light? A tiny, tiny wavelength of just 50 nanometers. To actually bend visible light, the implants inside the metamaterial have to be smaller than the light's wavelength. That means manipulating matter at the atomic scale, which requires incredibly advanced nanotechnology that we are only just barely beginning to master.
Okay, so we can theoretically hide from our enemies using nano-metamaterials, but what happens when we want to go on the offensive? What does the physics actually say about building the ultimate sci-fi weapons, like a handheld ray gun, or maybe even a Death Star?
Section 4. Phasers and Death Stars.
So, is there a physical limit to the amount of raw energy we can cram onto a light beam? Surprisingly, no. But the reason we don't have handheld ray guns or lightsabers today is painfully practical. It's all about power storage. We have an extreme lack of portable power packs. To fire a devastating ray gun, you'd basically need the energy of a commercial power plant sitting right in the palm of your hand. Right now, the only portable massive energy source we have is a miniature hydrogen bomb, which, obviously, is not exactly great for the user. Plus, if you pump that much energy into a handheld laser crystal, it's going to instantly overheat and crack.
But what if size isn't an issue? What if you genuinely want to vaporize an entire planet? Well, the physics actually allows for this, but the raw power required is just staggering. To build a true Death Star, a civilization would either have to harness a massive multi-stage hydrogen bomb, firing thousands of nuclear-powered X-ray lasers all at once, or, even more terrifying, they'd have to redirect a dying star's gamma-ray burster. A gamma-ray burster unleashes radiation second only to the Big Bang itself. So yeah, raw energy limits are quite literally the only thing holding a galactic empire back.
So let's just say a hostile alien civilization actually builds a Death Star, and they aim a gamma-ray burster right at Earth. Is there any possible way we could escape across the universe in the blink of an eye?
Section 5. Quantum Teleportation Explained.
While classical Newtonian physics gives a hard no to teleportation, the completely bizarre probability-based quantum world says yes. The absolute foundation for this is a phenomenon called quantum entanglement. Albert Einstein derisively called this spooky action at a distance. Basically, it means that two particles can vibrate in such perfect unison that they form an invisible umbilical cord. If you do something to one particle, the other particle reacts instantly, even if it's on the complete opposite side of the universe. It is this exact web of entanglement that allows physicists to actually teleport information from one place to another.
And the speed of progress here is just breathtaking. Let's look at the timeline. In 1993, IBM theoretically proved quantum teleportation was possible. By 1997, scientists actually teleported photons of ultraviolet light. Fast forward to 2004, and they're teleporting photons 600 meters through fiber optic cables beneath the river Danube. Then in 2006, they made a massive leap to macroscopic teleportation, successfully entangling a light beam with a gas of trillions of cesium atoms. I mean, think about that. We went from theoretical math to teleporting trillions of atoms in just over a decade.
But of course, there is a massive philosophical hurdle here, which we call the quantum catch. To successfully teleport the exact quantum information of an atom, or, eventually a person, the original information is completely destroyed in the process. You do not get a fax machine scenario with two copies. If you were to step into a hypothetical teleportation machine, the you in that room would literally be destroyed so that your exact atomic information could be perfectly reconstructed on the other side of the world. It really makes you wonder, who is actually walking out of the other side of that machine?
Ultimately, what this explainer shows us is that whether we're talking about force fields, invisibility, or teleportation, these are not impossible magic tricks. They're simply engineering challenges. Sir William Osler hit the nail on the head when he said, "The foolishness of yesterday has become the wisdom of tomorrow." What seems like an absolute absurdity today is often just waiting for the right scientific breakthrough.
And I'll leave you with this final, provocative thought to chew on. Everything we've covered today, teleporting atoms, bending light, containing plasma shields, these are all just Class 1 impossibilities. They could literally be achieved in the next century. So if we ever encounter a civilization that is a million years ahead of us, what kind of absolute magic will they be wielding? Thanks so much for joining me on this journey. Keep questioning the impossible, and I'll see you next time.